In this video, I will explain the basic concepts of graphing an inverse function. For a function to have an inverse, it must be 1 to 1, which means there must be only one x value for every y value. This sounds complicated, but it can be easily tested by using the horizontal line test, which means that if you draw a horizontal line through any point, it will only cross through one point on the function. For this example, if we drew any horizontal line, it would only cross through one point on this function here. That is how we know that it should have an inverse. So I will show you right here how to graph that y equals 2x minus 3, which is this line, has an inverse. Or I'll show you how to get the inverse. First, you want to solve for x by itself, which means we should add 3 to both sides and divide by 2. So we'll end up getting this. Y plus 3, all divided by 2, equals x. That can be rewritten as 1/2 y plus 3/2 equals x. Now all we have to do is switch the x and the y, which means that the new value, the new function, the inverse, y equals 1/2 x plus 3/2. So again, what I did here was you get x by itself from here to here, and then you end up, well, all I did right here was rewrite it. But then after that, all you have to do is switch to the y and the x, just switch them out. So I will graph this right here. Y equals 1/2 x plus 3/2. First of all, we should travel up 3/2 right here. And then we should go over 2, up 1, which is about right there. So as you can see, this is the inverse. Now, you can tell that these are inverses because what an inverse does is it reflects itself upon the y equals x axis. As you can see, it sort of reflects itself, more or less. So that is how you can switch from a function to its inverse. So now I have to ask you this, is y equals x squared, does that have an inverse function? Well, we should graph that right now. Sorry, this is going to get a little messy, but this is roughly that graph right here. Y is equal to x squared. Now, if we drew a horizontal line through, say, right here, we can see that it crosses through two different points, right here and right here. So this does not have a function, does not have an inverse. However, if you only took one side of it, that would still have an inverse. So my second example here is the natural log of x. This can be graphed, well, right here. It goes through 1. It should just keep going off right there to infinity. And this gets closer to 0 right here as it goes down. So that's approximately what the graph y equals ln of x is. But if we're trying to find the inverse, what should we do? Well, just like the last one, we found x by itself. So let's try that. Well, we know that if we had both of these as exponents for, say, e, so e to the y equals e to the ln of x. We know that e to the ln of x cancels out, so that's just x. So this is also rewritten as e to the y equals x. So now that we have x by itself, we can switch x and y. So our new function should be, I'll write it over here, y equals e to the x, which can be graphed like this. That is roughly what the sketch of the graph looks like. Now, as you can see, it does reflect upon the x-axis, the y equals x-axis right there, or the line. Thank you for watching this video. I hope you found it helpful, and please leave me comments or questions if you have any questions for me. Thank you.